As I've alluded to a couple of times, most statistical models used in psychology research and the social sciences use t-tests, ANOVA, and normal linear regression. Linear regression models basically fit straight lines through each predictor, like we did in the previous video. Often straight lines aren't a good fit. The relationship might not be a straight line, but curved, like a bowl or a hill. In geometry, these are called parabolic shapes. Other more complex shapes like exponential or logarithmic curves might be more appropriate. Let's look at the effect of legal gambling predictor, where we've included the cont version of this predictor to fit a straight line. According to the codebook, this question is answered on a Likert scale, where the respondents are asked whether the impact on legalized gambling is very good, good, equally good and bad, bad, or very bad. It looks like about 15% of respondents didn't answer the question, as shown in this less than zero category here, while most thought it was equally good and bad, this 3 category. What we can see is that the straight line doesn't fit very well at all. This is shown by the red and orange lines not matching up with each other for most of the categories. Recall that the red line is the actual gambling addiction score and the orange line is the modeled gambling addiction score for each category, to see what a better shape would be fit a categorical version of this variable as opposed to a linear line, and see what shape the betas take given full freedom, and then try to replicate that shape with a simpler model. So having fit the model, we see that between 1 and 5 we've got a bowl or a parabolic shape. From 1 to 2 it goes down a little bit, then it goes down a little bit more from 2 to 3, then it increases at 4, and then it increases at 5 again. Does this make intuitive sense? Just speculating about it for a second, why might people with moderate views on whether legal gambling is good for society tend not to have gambling problems, whereas people who are at either extreme, the 1s and the 5s, be more likely to have gambling problems? Maybe people in these categories who think legal gambling is great love the fact that they have easy access to their favourite hobby, and people in these categories who hate legal gambling have paid the price for their addiction and decided that society would be better off without it. It's easy to speculate why people with extreme positive or negative answers to this question might have a higher propensity for gambling addiction than people with more moderate views on the subject. I'll leave speculating about this to the psychology experts and focus on building a good model that fits the survey results and provides predictive power. We do this by fitting a spline, which is basically a curve. You can actually fit different curves over different sections. Maybe you want a straight line over this section, then a curve from here to here, and then an entirely new level over this bit. Now our needs are a bit simpler. There are 2 splines we want to try. One is to fit an upside down bell-shaped curve over the whole range, effectively a bowl like this. The other is to try fitting 2 straight lines, one from 1 to 3 along here, and then a second one from 3 to 5 along here. Let's create both separately and then decide which one is better. We create these derived variables by clicking on the cont version of the predictor and then clicking the create var button. Note that if you click the create var button from the cat version of the variable, you can group levels. If you click the same button from the cont version, you get this screen instead. Let's fit the bowl shape first. We can specify the range we want the curve to fit over. A parabola or a bowl is a quadratic curve, so we leave the range from min to max and select quadratic as the shape. Min to max means just fit the quadratic over the whole range of effects of legal gambling rather than worrying about fitting different curves to different sections. We'll fit different curves to different sections in the second example, where we'll populate this row here and we can look at how other rows will be populated down here. Let's call this parabola effects of legal gambling and click create variable. We can see that it has appeared down here. Let's tick this untick that one, click Fit GLM, and see what comes out. Now we've got this bowl shape, also called a quadratic, also called a parabola. Let's try fitting two straight lines now, one from here to here and one from here to here. To do that, click the cont version again, click Create Var. We'll call this Linear Effects of Legal Gambling. We want to specify the range over which to fit each section. So if we put 3 here, we're fitting one line from min to 3 and the second line from 3 to max. We'll fit a linear line to this one and a linear line to here. Linear just means straight in this context. If we wanted to fit, say, 3 sections or 4 or 5, we can click Add Section and more rows would be added down here. But we only want 2, so we don't need to click Add Section. And you can delete sections by selecting these and clicking Delete Section. Let's click Create Variable. Let's click Linear Effects of Legal Gambling. Now this looks similar to what you saw before, but instead of a bowl-shaped curve, we now have 2 straight lines. This fit looks pretty good. We can see here that the red and the orange have lined up extremely well, except for just this one category here, but apart from that, everything else looks really good. In a later video, we will discuss a rigorous way to choose between alternative models. Fitting splines is one of the more complex features of Preddle. The spline fitting video in the Business Data tutorial series contains a couple of examples in fitting splines to insurance claims data. That video will be worth watching for additional examples.